Hi everyone, my name is Nicholas Obeso. I'm an industrial engineer at PMC. I'm joined today by Fred Jansma. We're going to start off with some of the topics that we're going to be discussing today. First off is going to be an in-control and PMC introduction. Then we'll go over some challenges in the industry. We'll do a brief overview over enterprise dynamics with a live demo along with some case studies. And then finally, I'll be handing things over to Fred, who will talk to you all about the future of simulation. So now, without further ado, I hand it off to Fred, who will talk to you a bit about in-control.
Thank you, Nicholas. Well, in-control enterprise dynamics was founded in 1989. And from the start, we were always in quantitative analysis, giving advice to our customers based on hard data. That resulted in becoming a reseller of simulation software. And at the end of the last century, we became a manufacturer of simulation software, and we introduced enterprise dynamics to the market. Enterprise Dynamics is a discrete event simulator that we used to simulate material handling, warehousing, manufacturing, etc. And it was later on was added an agent-based simulation product called Pedestrian Dynamics, which is used for crowd simulation. Next slide, please. We do this for customers around the world with some very well-known names like Knapp, Walmart, Cencora, but also UEFA, FIFA, NFL. And we do this also together with a lot of universities. Around 400 universities around the world use Enterprise Dynamics. We can't do that alone, of course, and for that we have a lot of partners, of which PMC is one of our long partners from the US. Together with some other customers like BRC and partners Little Caesars Arena. A brief overview of who we are and where we are active. Nicholas, to you.
Right. Thanks, Fred. So now a brief introduction to PMC. Since 1979, PMC has helped over 700 companies by completing more than 8,000 performance-enhancing initiatives worldwide. Our commitment to excellence has brought us to the point where we are now the largest independent industrial engineering services firm in North America. In addition to our US location, we also have engineers in Mexico, Brazil, and India. PMC has worked with hundreds of customers across all sorts of industries, but here is just a selection of our current and repeat customers. Specifically with In-Control, our partnership with them has stretched back over 30 years. And you could probably tell from my picture, but I've not been around that long. In my case, I first received training on In-Control software, both ED and PD, 2 years ago, and I've been enjoying working with those products ever since. Today's session will focus on Enterprise Dynamics, but we are going to continue first with a sampling of some of the other services that we offer. So we have a wealth of services to offer, and the experience and expertise to go along with it. Some of these services include factory design, laser scanning, and CAD modeling. And then, of course, also traditional industrial engineering services. If you're already underway with any productivity improvement initiatives in your company or are wondering where to start, please reach out and we can certainly help you. Now, moving on to challenges in the industry. Firstly, kind of big change right now is AutoMod being discontinued. We all strongly believe that Enterprise Dynamics, or ED for short, is an excellent candidate as a replacement to model and find solutions to any number of these industry challenges and many, many more. You'll learn over the course of this presentation that ED can already do a lot, but with skilled modelers and programmers, you can get it to do a whole lot more. So now we'll go into a showcase of ED, starting with some of its features and advantages. First important feature is really how scalable it is. Enterprise Dynamics can model individual lines all the way up to entire operations at a massive scale, and that's something you'll see in one of these case studies. It really does demonstrate just the sheer number of moving parts that ED can handle and can handle without breaking a sweat. This comes down to just how efficient it is and how it runs and how it stores and recalls data. I've seen a whole fulfillment center with millions of SKUs being pulled and accessed standard laptop. Next is the open simulation objects and user interface, and the ability to change and develop entirely new simulation objects. These kind of go together in my mind. So ED is usable by a novice, but you can really get under the hood. It is, in that sense, really a developer's platform. So you can look into the code for any of the default objects to see how they work. You can adapt them into new objects or subclasses. And you're also able to customize the GUI of any object or the entire program's user interface, even down to the splash screen. So again, really full control of what's going on here with this software. And then we have complete control of simulation events. Again, nothing is really hidden from you here. You can create new events for objects or modify when existing ones are triggered. And ED includes a real-time debugger that not only does it show the code in an object being run, but it also shows what events are scheduled. So again, you are omniscient when you're using this software. You can see just about anything, change anything. It's just full control. ED also has support for the various industry standards. So it supports XML, TCP, IP, and OPC, etc. And it's also able to communicate with real-world systems and databases. So here are some of the industries that ED gets used in: material handling and logistics, which is going to be a bit more of the focus of this presentation, but then also, of course, manufacturing and transportation. So moving on, we'll go to a live demo. So I'm going to pull out of this, and this is just going to be something very brief showing what ED looks like. So this is the view when you boot up ED. By default, we have the 2D builder window here in the center. We have a clock, which just shows the time that's elapsed. That can be changed into a digital clock, etc. We have the library tree, which is where we access all of our objects and bring them into the modeling view. And then we have our run controls here on the right. And then lastly, the ribbon on top. So as I said before, any of these GUI objects can really be customized. So if there is, for example, something here on the ribbon that I don't need, I can take that off. Or if there's something that isn't there, I can add it in. I could even change the color of everything if I so desire. So we'll start off very briefly with making a very small basic model. So we'll go into the basic modeling tab. And this has, if you're already coming from another discrete event simulation software, this has some of the objects that we're used to seeing. So a source, which I'll drag in. We'll drag in a queue. We'll do 2 servers. And we'll pull these a bit further back. And then a sink to end things off. And I will reset. And what that's going to do, if I press the keystroke is Control R, but you can also just show it here. It'll show our channels. So already there's something here that I want to change. These servers are arrayed in sequence. I want them to be parallel. So what I'm going to do is add a channel to this queue and connect it to the input of this server. And then this sink also, I need to add another input and connect the server there. So now we have a very basic layout setup. Just also a side note, all the units in this is all to scale. This is all in meters, so each one of these grids corresponds to 1 meter. So what I'm going to do is press display and pull up the 3D viewer. And this is what the visualization looks like. So again, our source, our queue, our 2 servers, and our sink. These are the default 3D graphics. There are a number of options that come preloaded for For example, the server, we can change it to look like a drill press, for example, and also we're able to bring in any number of 3D file types and pull in our own custom 3D models. So what I'm going to do is switch our run control. So we are doing, say, 10 simulated seconds per real second, and we'll run it. And what we'll see is, if I then close this out again, only this server's utilization is going up. So what has happened here? If we stop this and look into the queue's user interface, again, this is something that we can edit ourselves. But we'll see that the send to, which is the routing from the output to the next object, just says 1. So it's only sending it to this first server. So let's change that. We can bring down a drop-down menu, and this has a number of different options that we can select. So these are commonly used logic. So let's do a random channel. And one thing we can do as well is see what the underlying script is. And if we so desired, we could go in and write some custom logic here to decide that. But we are instead going to just select this, close it, and press OK. So now, if we pull this up a second time, we'll pull up the 3D view again. It's going to both of these servers, and these are very nicely animated. Now, what if we wanted to have some conveyors down, because right now things are essentially teleporting? Well, let's add those in. So let's move these out a bit further to give us some room. We're going to now go to the transport tab. This is where anything that transports is stored. So there are forklifts are going to be here under floor bound, but then conveyors is what we're interested in. So we have 3 then further subcategories. We have accumulating and non-accumulating conveyors. Then we have, so let me expand these. And then we have our intersections. So these are lifters, so kind of an elevator that sits on the conveyor, and then corner transfer units. So let's pull down a non-accumulating conveyor. This is by default 10 meters long, and I think I'm going to leave it like that. Let us go to the queue, switch this back to 1 because it's just sending to that one conveyor now. So we can get rid of that output channel and connect that here. And now let's add a corner transfer unit. That's going to connect to the end of this conveyor. We'll add a second output channel, and now we'll add 2 more conveyors on either side of this. Let's shorten this to, say, 5 meters. Let's add a second one down here. Connect that one up. And now we'll connect these conveyors to their respective servers. Let's remember to go into this corner transfer unit and see what the send to strategy is. Again, it's 1 by default. So what we're going to want to do is actually reset. And we'll choose an open channel randomly. So let's close. Let's pull back the 3D viewer. So now if we run, we'll see the entities moving down the conveyor. By default, the transfer unit has no transfer time, so they're blipping, but that can be changed so that there is some delay as they move through. But very briefly, that is what we have. Now, I spoke before about the customizability of the objects themselves. So that is done with an atom editor. And atom is the ED terminology for object. So if I click on one of these, go to tools, I can open its editor. This also shows the model view. So what we had before was the library tree. That is where we're bringing objects into the model from. But then the model tree is the objects that are actually in the model currently. So here is the atom editor, this kind of area here. Here is where we would be able to add 3D visualizations to these objects. We could also change to 2D. But here is where we see all of the underlying code. So if I want to make a server that functions maybe slightly differently, I can subclass this one and start from there, but I can also look through any of this code and pick and choose the things that I want or want to modify. So it becomes very, very easy to get off the ground and start making your own custom objects. And when I received my training, I was just within a few weeks making custom objects like this. And then the last thing of note to show is that aforementioned debugger. And so this is where we'd see an event list and we'd be able to debug code in here. So that is just a quick, brief overview of Enterprise Dynamics, some building that we can do in here. So it's very easy to get started. You're dragging things in, but you can go very in depth. And some of these case studies that we're going to show now in a second are really going to show just what can be accomplished with this software. So let me. So in summary, the benefits of Enterprise Dynamics are its open architecture and the ability to expand the tool with your own code. So you're able to get any desired functionality out of this software. If there's an object or feature that doesn't exist by default, you're able to easily make it from scratch, or as I said, you can take bits and pieces of pre-existing objects. And then it is suitable for very large and complex simulation models, as we will see in just a second. Okay, so now we'll be getting into the case studies. So we have two to show you today. The first one is a crate washing line model that was done for Kühne and Nagel. So we'll go now into the video. So this was a model of a central hub of a food bank. What we're seeing right now is a top-down with some kind of real-time statistics that are going on. So these are crates that are used for delivering groceries to families in need that are being washed. And so this is a pick and place operation. We're going to see this now in 3D. We have some robotic arms pulling off these pallets and sending them down. And these are all default objects in ED. So we have a combination of some accumulating conveyors. So we see the rollers there and these robotic arms pulling them off. And so in a few seconds, we'll then see sort of the second half of this operation, kind of what is going on here by where these green boxes are. So now we're shifting over and we are getting to the depalletizing operation as well as the splitting. And here, this de-stacker, I really do quite like the animation that's here as they come off one by one. Okay, so this next one is a fine example of the scale that can be achieved in Enterprise Dynamics, both size-wise and also complexity. This is a model of a baggage handling system at Amsterdam Airport Schiphol, which is one of the busiest airports in the world, both in terms of passenger traffic and cargo. It's a major hub in Europe. So a lot of flights that aren't necessarily going to the Netherlands will end up there, for a transfer. And so this model in particular has 250 kilometers or 160 miles of conveyors. So this was commissioned by the airport and KLM, the Dutch Royal Airline, to provide a tool that can provide neutral insights, separate from politics or anything like that. This has been in use for more than 20 years. It's been consistently updated as they make design changes and additions to the baggage handling system. This model saved the airport 50 million within the first week of use. So this has become now the oracle that gets consulted anytime they have any major changes. They will test them out here before they're going and spending any money. So everything in this system, in this airport, is simulated now because of how successful this simulation was. And this has been going on for so long that as this flyby goes through, you'll see some 3D that looks maybe a bit more detailed, a bit more sophisticated, and the difference being when that part of the baggage handler was modeled. So there's the early sections of this model and then ones that were made more recently, and there is a difference visually in 3D. I should add that outline of the airport is an example of CAD being brought into this software as well. That's one of the nice tools that ED supports, is bringing in CAD, and it's to scale by default. So on to the next slide. So just for another brief summary before I hand things over to Fred. So simulating with Enterprise Dynamics, as we said, we're able to model an entire facility in one model. Size really isn't an issue, at least not for anything that humans make. ED supports 2D, 3D, and VR for visualization. So there's support for Oculus, for example. Using ED, we can create our own reusable objects. So something that I make in one model, I can save as a file and load it into another model. We can create our own simulation applications with it. So as I had said before, the level of customization, specifically with the GUI and user interface, is so much that we can completely reskin the software and make it so that it is focused for a particular use case or client. And then lastly, Enterprise Dynamics can be used for not only simulation, but also emulation. So now I'll hand things over to Fred, who will tell you about some of the new exciting things that In Control has in store in the world of simulation.
Thank you, Nicholas, for your introduction to Enterprise Dynamics. As a bonus, I want to talk about some of the things that we have been doing for the last 12 years. I'm myself working in the world of simulation for more than 27 years, and in this time I've only see the same software. Well, we have been working hard on a new simulation platform capable of utilizing modern hardware and finally be able to run models in parallel. Next slide. So for years, every time when an Intel processor came out, we all had bigger models, faster models, but when multiple cores were utilized, we all fell back because the speed of the CPUs went back. It was impossible to utilize multiple cores within a processor and still be deterministic and guarantee results tomorrow and the day after. So that has been a long journey for a lot of scientists, academics, experts in simulation. And we all have been looking on how to utilize multiple hardware. And today, next slide, please. I want to introduce you to ERS, Enterprise Resource Simulation Platform. ERS is a paradigm shift in the world of simulation. It's used. It can be used to simulate real parallel models. We also came to the conclusion that instead of building up a generic simulator, it should be best to build up a simulation development platform with which you can create your own specific simulators. We want to have more influence on how our simulations are running, how we can utilize hardware, but also use it cross-platform. So we decided to make it a simulation development platform. In short, next slide, please. Enterprise Resource Simulator is a scalable cross-platform simulation development platform utilizing multi-formalism and real parallel simulation. So not that you run a model in parallel 10 times. No, the model itself runs parallel. We do that with a new architecture that allows us to expand the platform easily, but also natively. We have an SDK that allows new features to be brought in, and also to add new support for new standards, etc. We also do that in a way that we offer that SDK to our users, so that they can utilize the ERS simulation core and integrate it with their own software, but also expand that software in a way that they seem to fit best for their specific purpose. To give you a comparison of what is possible with ERS, we have made some test results, and in comparing Enterprise Dynamics, our own simulation tool that we sell today, with ERS, whereas we script a number of submodels, and in each of these submodels you can enter the number of conveyors you want to have, basically the same as what Nicholas did in his demo, and we can enter a simulation length. And we did that as truthworthy as possible, that you have a completely comparable ED model with ERS. And we tested it on different hardware. So at first at a 3-year-old laptop, a game laptop with 8 cores of 16 gigabytes. We also did that on a 2-year-old Threadripper with 64 cores and 256 gigabytes of RAM. In the last one is a very modern i7 desktop with 16 cores, 64 gigabytes of RAM, which is the real powerhouse. So it's the fastest computer that at that time we had. So we did some testing, 100 submodels with 10 conveyors, which resembles roughly 2,000 simulation objects at any given time within the simulation model. An ED, to run that for 10,000 simulation seconds, it only costs 16 seconds, which is quite good for a simulation tool if you compare it also to other products in the market. However, that same model in ERS runs in 3.5 seconds. If we scale it up 10 times with 1,000 submodels, 10 conveyors, so at any given time, 20,000 simulation objects, it takes Enterprise Dynamics 400 seconds in comparison to 28 seconds on that same laptop, and on a desktop it will only take 16 seconds. Once more. We could scale it up even further to 200,000 simulation objects at any given time within the simulation model. That will take Enterprise Dynamics almost 2,000 seconds. Still in ERS, it's gliding smoothly, 67 seconds. Still only 26 seconds if you would buy faster hardware. However, if you also look at memory comparison, ED in this case uses 4.4 gigabytes of RAM. It only uses 600 gigabytes of RAM within ERS due to a much more efficient memory model. So not only is ED takes more memory in comparison to ERS, ERS is also much faster. So you can scale up more and have a faster run speed. So let's continue. So 2 million simulation objects at any given time within the model. Well, this simple game laptop says no on Enterprise Dynamics. It runs simply out of memory, and still it runs in 465 seconds on ERS. But the last two columns are more interesting. Up to now, brute force of the hardware of the i7, the desktop, won over a 2-year-old Threadripper. However, if we size up more, now in this case with 1,000 submodels, the Threadripper only slightly takes more memory than 200,000 seconds, whereas on a desktop with less cores, it takes a bit more. It's almost double the time. This proves that with more cores available, with bigger models, you can scale up much further. At this point in time, our biggest model is 280 million simulation objects, faster than real time on the Threadripper. And we simply ran out of memory, not out of speed. So we're now cooperating together with the university with bigger hardware to see what will it go to. But for the moment, with 280 million simulation objects faster than real time, I assume we're at least a little bit further down the road than we have with the current simulation tools. So we're working hard on this for a long time. We started 12 years ago. We finally have it. We bring it now slowly to the market. You're one of the first to see it. And it is a future that is coming out of our development lab that we will bring to the market in 2024. So this is a little bit about our future. Nicholas?
Right. So now we're going to finish things up, at least with the presentation, with a recap and closing. So if you want to get started now, Enterprise Dynamics is the way to go. You can get that off the shelf and start modeling. And with Enterprise Dynamics, you already have a feature-rich simulator. You can drag and drop, and you can get in more in depth and do some real custom modeling and development in it.
And for ERS, it's a development platform. That means that it's not an off-the-shelf product. You have to build up your own simulation application. But if you do that, you have the future of simulation within your capabilities. Within a multi-formalism support, like discrete event, agent-based, continuous emulation, all running in parallel on a cross-platform way. So that's a little bit more effort, but it also gets you ready for the future.